You tap a button on your phone, and a few days later, a replacement car part or a winter coat arrives on your porch. The mental image of how it got there is usually pretty simple: a factory, a cargo ship, and a delivery van. But right in the middle of that journey is a massive, hidden bottleneck. It is a physical system of staggering scale, and you rely entirely on it for almost everything you buy, even if you've never seen it operate up close. A modern container terminal functions as a highly automated physical router, orchestrating a high-speed exchange of steel blocks that weigh up to 30 tons. To an observer, it looks like a complex three-dimensional game, and getting your package on time depends entirely on this system's ability to maintain its rhythm. To understand how this hidden system actually works, you have to look at the operational problem it is designed to solve. A single modern megaship pulling into the dock can carry up to 24,000 shipping containers at once. This visualization shows the true scale of that cargo. If you took all the boxes off just one of these vessels and lined them up end to end, that line of steel would stretch for 90 miles. When that ship docks, the clock starts ticking. A vessel sitting idle at a port burns through tens of thousands of dollars every hour. Because of this cost, the port is given a shockingly short window, often just 24 to 48 hours, to pull thousands of specific boxes off that vessel, safely store them in a severely limited footprint, and load thousands of new boxes back on. If a port simply unloaded those containers and placed them wherever there was open space, finding one specific box for a waiting truck later would be impossible. The entire global supply chain would instantly gridlock without a strict, multi-step physical and digital filtering system to control the chaos. Absolute, unforgiving standardization provides the mechanical logic necessary to move millions of boxes across the globe. Every single shipping container on Earth, whether it is carrying flat-screen televisions or auto parts, is built with identical steel corner castings. These are heavy, hollow sockets welded into all 8 corners of the box. These corner sockets allow the boxes to be locked to ships, trucks, or each other using a brilliant piece of hardware. A heavy metal cone slots into the corner casting. When turned, the cone rotates 90 degrees, physically locking the 2 steel pieces together. This simple locking physics is the foundation of the physical internet. When a ship docks, teams of human dock workers move through the vessel, manually disengaging these heavy steel pins so the boxes can be freed, triggering the automated pipeline. As soon as the boxes are unlocked, the towering ship-to-shore cranes lining the water function as precision-engineered sorting valves. An operator sitting 150 feet in the air lowers a massive rectangular frame called a spreader bar. The spreader expands to fit the length of the container, drops its own twist locks perfectly into the top 4 corners of the box, and hoists up to 30 tons of cargo into the air in seconds. Decades ago, this crane would drop the box directly onto a truck driven by a human. But human drivers are unpredictable. They get lost, they park slightly out of alignment, and they slow down the cranes. At the scale of modern global trade, waiting on a human driver is simply too slow. Today, many ports remove humans from the waterfront entirely. The crane drops the box onto an automated guided vehicle, or AGV. These heavy-duty robots look like massive flat metal tables rolling on heavy tires, with no driver's cab and no steering wheel. This diagram illustrates how the AGV navigates away from the water. These machines find their way by reading a hidden grid of thousands of highly sensitive transponders embedded in the concrete, which light up as the robots roll over them. A central computer reads these transponders to choreograph the exact movements of dozens of heavy robots simultaneously. This total automation at the transfer point allows the port to synchronize dozens of heavy machines with a precision humans cannot match. The AGVs route the boxes to the container yard. Because a port is given a finite amount of expensive coastal real estate, they cannot expand outward. They must build upward, stacking containers in massive, deep blocks up to 6 boxes high. A stack of 6 loaded containers weighs nearly 400,000 pounds. That concentrated pressure would instantly crush standard highway asphalt. To survive this continuous weight, the yard is built on a heavily engineered slab, poured over deep pilings anchoring directly into solid bedrock. The ground itself is a massive infrastructure project, specifically designed to never flex, crack, or sink under the weight of a continuous steel avalanche. Only with that indestructible foundation can the yard safely support the stacking. But stacking creates a logistical nightmare. If a truck driver arrives to pick up a box at the very bottom, the port must move 5 heavy boxes out of the way just to reach it. This wasted movement, known as friction, can grind operations to a halt. The Terminal Operating System, or TOS, maps the physical yard into a coordinate grid to solve that exact problem. It tracks boxes and color shifts them based on priority, orchestrating the entire future timeline of a box before it even docks. The system uses this timeline to perform predictive sorting. Boxes scheduled to sit in the port for a week are buried at the bottom of the stacks, while boxes scheduled to leave immediately are placed on top. But schedules change and trucks get delayed. To keep the flow perfect, massive robotic automated stacking cranes spring into action every single night. Working entirely without human input, they spend the quiet hours doing housekeeping, lifting heavy shipping containers through the dark and shuffling tomorrow's cargo. Thousands of tons of steel move through the dark, guided by code. This automated nocturnal sorting maintains the perfect daytime flow required to manage unpredictable human truck schedules. There is a major physical exception to the stacking system. A significant percentage of global shipping consists of perishable goods, frozen meats, fresh fruit, and pharmaceuticals. These travel in specialized refrigerated units called reefers. Reefers lack internal power sources. They need constant electricity. They are routed to specialized reefer racks, where human workers walk along multi-story catwalks to manually plug thick, heavy-duty power cables into every single unit. If a reefer loses power in the middle of a stack, millions of dollars of cargo rot. Keeping the cold chain alive forces the port to operate as a massive utility grid, drawing enough electricity to power a small city. All of this highly tuned automation is useless if containers cannot smoothly transition onto the highway. The truck gate represents the final boundary between the automated port and the human world. While drivers once stopped at booths to hand over paperwork to clerks, modern gates are optical machines. The approaching truck doesn't even stop. This 3D isolation shows the truck driving through a specialized portal, equipped with high-speed cameras and optical character recognition. Graphic beams simultaneously scan the license plate and the specific serial numbers painted on the container, while weigh-in motion sensors beneath the tires instantly register the weight of the chassis. Registering dimensions, identity, and weight in milliseconds prevents miles-long backups of idling trucks on surrounding highways. The terminal operating system verifies the driver's appointment, flashing yard coordinates onto a digital sign. The human driver navigates to that exact slot, where their specific box is already waiting, perfectly positioned at the top of the stack, thanks to the previous night's housekeeping. The automated yard crane glides over and lowers the 30-ton cargo flawlessly onto the metal pins of the truck chassis. It releases its twist locks, and the driver manually locks the physical pins before pressing the accelerator. From the moment the ship arrived to the moment the truck pulled away, that steel box was sorted, routed, and loaded by this massive physical machine. A continuous interplay of digital logic and heavy infrastructure operating flawlessly out of sight.